Okay, now first determine domain. Okay, domain. Domain is all real number except the restriction. The restriction is when the denominator is 0. And you solve this equation. It's obvious that the solution is plus or minus 3. Okay, this is the restriction. Domain then is all real number except. So all real number except plus or minus 3. If you want to express it, this idea in interval notation is from negative infinity, comma, negative 3, union, from negative 3 to positive 3, union, to positive 3 to infinity. Okay, we have two holes, and positive 3 and negative 3, that's it. Okay, now x and z and y and z. Y and z first, it's easier. G and 0. It's obvious it's 0 because 0 divided by 0 squared minus 9 is 0. 0, comma 0 is both x and z and y and z. Just in case, let me try to investigate x and z is when the function is equal to 0, but the function is x over x squared minus 9, and when the fraction is 0 is because the numerator is 0. Again, we have 0, 0. 0, 0 is the only point that we have intersect. Okay, let's go to the vertical asymptote. Vertical asymptote, remember the 0 of the denominator that we computed before that was plus or minus 3. So you need to investigate the behavior. So you apply the limit. When the x approaches to 3 plus to the right of our expression. This is 3 over 3 plus square minus 9. 3 plus is a number a little bit close to 3, but a little bit greater than 3, 3.1 suppose. When you square this number is greater than 9, this is 3 over 0 plus, and this is positive infinity. Okay, now exactly the same. Limit when x approaches to 3 minus to the left, x over x squared minus 9. This is 3. Oh no, actually I put positive or negative in the bottom, and at the top no, because no, it's totally irrelevant. So it's 3 minus square minus 9. 3 minus, for example, 2.9. And the square is less than 9, so this is 0 minus. 3 over 0 minus. 0 minus means a number close to 0 but negative. It's negative infinity. Likewise, we can determine, for example, limit when the x approaches to minus 3 to the right of the x over x squared minus 9. This is 3 or minus 3, sorry, divided by minus 3 to the right square minus 9. This is negative. This is negative here. Okay, good. This is negative. This is a number, for example, negative 3 plus is a negative plus. Negative 3 plus is negative 2.9 something. When you square, this number is less than 9. This is negative. This is negative 3 over 0 minus is positive infinity. Okay, now the limit. Well, cuando x approaches to -3 to the left of x over x squared minus 9. This is -3 again. This is -3 minus 9. This is a square. Okay, -3 minus is like a -3.1. When you square become greater than this is 0 plus. -3 over 0 plus is negative infinity. Okay. This is the analysis for the Beric acid. Entonces, what is que summarize everything about the Beric acid is, let me see here. We have -3, +3. Beric acid. Entonces is this guy infinity. Like that. 3 left is negative infinity. Like that. 3 plus is positive infinity. And 3 minus is negative infinity. Okay, this is the picture to summarize everything about the Beric acid. Okay, let me try to investigate now horizontal acid. Horizontal acid. Horizontal acid is limited when the x approaches to infinity, positive or negative. Es obvio que sí. Apply dominant is x over x squared is 1 over x. When approaching to infinity is 0. 0, 0. To complete the picture now, entonces es 0 and 0. This is approximately the idea for the acid. This is the horizontal at y equals 0. Y equals 0. Okay. Okay, now let's go to the calculus part. Compute the first derivative. You apply quotient rule. X squared minus 9 squared. Derivative x with respect to x is 1 time x squared minus 9 is the denominator expression minus x times derivative this is 2x. X squared minus 9, and the top we have x squared minus 9 minus 2x squared. We combine like terms, so we have x minus x squared minus 9 over, and this is square, sorry, x squared minus 9 squared. This is the expression for the first derivative. If you want, you factorization this negative outside, and let's take x squared plus 9, x squared minus 9 squared. Okay, and you can see that this never is 0. No, impossible. And never is positive. Always is negative. Okay, for any value for the x, because this expression is positive, this expression is positive, this state is negative. That means that the function is decreasing. That's the first conclusion. The second conclusion, since it's not 0, we have no critical point, therefore we have no max minimum. Okay? Okay. Perfect. Okay, now let's compute the second derivative. Again, we apply quotient rule. x squared minus 9 raised to the 4th power, square square. And derivative this is, derivative at the top is 2x. Okay, stay this negative. Okay, this negative stay. One negative is outside stay. Derivative this is 2x. Multiplication by x squared minus 9 squared minus this stays the same, x squared plus 9 times the derivative of this expression is 2, okay, is power, entonces look, 2 times x squared minus 9 raised to the 1 power times derivative, this is 2x. Okay. And that's it. Okay. Now with factorization x squared minus 9, 1, because we have 1 here and 2 here. Now we have inside 2x times x squared minus 9 one time minus x squared plus 9, okay, this is this, and 2 times 2 is 4x divided by x squared minus 9 to the 4th power, and we cancel out one of this and one of this, stay 3. Now I try to distribute here and combine later. This is 2x cubic, because this time this is minus 18x. This time this is minus 4x cubic, and this time this is minus 36x. We combine, so we have minus here, minus. Inside we have, let me see, 2 minus 4, negative 2, x cubic. 36 and 18 is 54, minus 54x, over x squared minus 9 cubic. Wow, this minus and this minus is gone, so the second prime is 2x cubic plus 54x divided by x squared minus 9 raised to the 3rd power. If you want factorization, 2x in the top is x squared plus 27 over x squared minus 9 cubic. Okay, ready to continue. Okay, the critical value for the second derivative r, when the 0 here, 0, is so because x equals 0 here, and critical value here is plus or minus 3, so it's x equal positive 3 and x equal negative 3. Okay, this is the critical value. I apply the second derivative test, 0, in order to determine the concavity, negative 3 and positive 3. And you determine testing point, maybe negative 4, maybe negative 2, maybe positive 2, and maybe positive 3. Positive 4, sorry. And you evaluate the second derivative in this value, negative 4, negative 2, positive 2, and positive 4. To make sure this video, I plug it in the calculator, I get the answer. I encourage you try to verification. You put this expression and plug it in -4. And the answer is -1.003. The answer is 0.993. The answer is -0.993. And the answer here is positive 1.003. Okay, those are the concavity. Concavity is negative, is down. Positive, up. This is negative, down. This is positive, up. Actually, this is no inflection. This is inflection point. Let me see. This is inflection point. Yeah, this is inflection point. Okay, but this is no inflection point because this is vertical ascendant and this is vertical ascendant. It's another possibility to change the concavity. Okay, let's see now definitely the simulation of Desmos. Okay, I type in the original function here, and this is the graph. Okay, and no maximum, no minimum. The function is always decreasing. Okay, we have only one x and y, let's say is 0,0, and the second derivative expression when it's negative is concave down. Concave down. Orange color. Concave up when the second derivative is positive. There you go.